Hope you're having a productive day. In this video, we'll be doing another past paper question. This will be question number 4 from the Unit 1 Physics Paper 2. Let's get right into it. First thing the question asks us to do is state fully what is meant by the expression, the principle of moments. Then it asks us, with the aid of an appropriate diagram, use the principle of moments to explain how it is possible for a person of mass 50 kilograms to lift someone twice as heavy on a seesaw. Now, the principle of moments states that if a system is in equilibrium, then the sum of clockwise moments is equal to the sum of counterclockwise moments. That's basically the principle of moments. Then it says, with the aid of an appropriate diagram, use the principle of moments to explain how it is possible for a person of mass 50 kg to lift a person twice as heavy on a seesaw. Let's get into that right now. I'm going to draw a diagram of a seesaw, and then I will now draw the fulcrum. So the fulcrum should be about halfway, maybe about here. And now we have a person. Let's say the bigger person is going to be this big circle. This is the bigger person, right? The distance that this bigger person is from the fulcrum, we will call that distance x. Now, according to the principle of moments, if the system is in equilibrium, the counterclockwise moments, which would be this because his weight is acting downward, so the downward would be the counterclockwise. The counterclockwise moments, which would be from this person here, would be equal to the clockwise moments. The clockwise moments would be from a person here, since their weight would act downward. But how would it be possible for a smaller person to lift a heavier person? Well, moment is equal to force times perpendicular distance. So moment, we can just call it T for torque, is equal to force times perpendicular distance. Now, if the mass of the person over here is 2 times the mass of the person here, then the force generated by this person will be 2 times the force over here, right? In order for the smaller person to lift the heavier person, the smaller person must have a moment that is greater than the moment of this person. If their mass is 2 times the mass of the smaller person, then the force is 2 times that. So what could we do to make the torque on this side, or the moment on this side, more than the moment on this side? We can just double the distance, but we would have to go to more than double the distance in order for us to lift this heavier person. If the distance was doubled, then the system would be in equilibrium. But if the distance is more than doubled, then the system is going to not be in static equilibrium, but it will actually tilt, right? So the person over here, let's call them the smaller circle, the distance is going to have to be greater than 2x. That's what this is, greater than 2x. Now, if this distance is greater than 2x, then the system will move in this direction. So this person's weight will push the system down, and because they're at a distance greater than 2x, the system is not in equilibrium. So the seesaw will tilt down this way, meaning that this part will go up and this person will be lifted. Part B, state the law of conservation of momentum. 2 objects of masses m1 and m2 respectively traveling in opposite directions collide. The respective velocities of the objects before the collision, u1 and u2, and after, v1 and v2, are given in table 3 below. This is the table here. Assuming that the law of conservation of momentum applies for this collision, calculate the ratio of the masses of the 2 objects m1 to m2. Calculate the total kinetic energy of the 2 objects before the collision, given that m1 is equal to 8.5 kilograms. And was this an elastic collision? Explain why or why not. Let's get into this question right now. Now we're dealing with a separate topic here. The topic over here was moments. This topic is momentum. Moments and momentum are 2 different things. In order to solve this question, let us draw some diagrams. I'm going to draw the 2 objects before the collision and after the collision. So before the collision, let's say we have one mass here, and this mass is going to be m1. It has a velocity that is stated to be 4 meters per second. Now we have another mass, m2, which is also going to be in the collision. m2 is traveling with a velocity of negative 3 meters per second. The negative 3 meters per second means that it's going to be in the opposite direction to what we designate as positive. So we designate right as positive. So if it's not going in the positive direction, that means it must not be going right, which means it is indeed going left. So this is going to be the velocity of the second mass. And that velocity is 3 meters per second. Now these are the two objects before the collision. Let us draw another diagram for the two objects after the collision. We're going to draw M1 again, but it has a different velocity this time. Its velocity this time was stated to be 1.5, but it's negative 1.5, so of course it's going to move in this direction. The other mass, M2, we will redraw that as well. And its velocity is now stated to be 5.5 meters per second. And it's positive, so it moves in that direction. Now from these, we can basically write out some equations. But just stating it before I write it, let's state it. The law of conservation of momentum states that as long as there are no external forces involved when the objects collide, the total momentum before the collision is indeed equal to the total momentum after the collision. Momentum, if you don't know, is equal to mass times velocity. So now we can write out some statements. M1 times the velocity of M1, which is 4 meters per second, plus M2 times the velocity of M2. Now the velocity of M2 is 3, and it's because the velocity of M2 is 3 because it's moving to the left, it's going to be negative 3. So it would be M1 times M4 minus M2 times 3. This would be plus M2 times negative 3. But the negative 3 would just make the M2 negative, so we just have the minus here. Because if you add a negative number to something, you're subtracting. So this is M2 times 3. Now this is the momentum before the collision. It is equal to the momentum after the collision. The momentum after the collision would be M1 times negative 1.5 meters per second plus M2 times 5.5 meters per second. Now we can basically rewrite the data so that it's a little bit more workable. And that would just be 4m1 minus 3m2 is equal to negative 1.5 m1 plus 5.5 m2. All we did was just multiply these numbers. So we multiplied the m1 by 4, we multiplied m2 by 3, so on and so forth. Now we want to get m1 on one side and m2 on the other. And the reason we're doing that is because we want to find a ratio between m1 and m2. In order to put m1 on one side, let's put the m1s on this side. In order to put the m1s on this side, we're going to have to take the m1 from here, and we're going to have to do something to this side of the equation so that we remove m1 from this side and that it ends up over here. Now that thing that we're going to do is we're going to add m1 to both sides. We're going to add 1.5 m1 to both sides. So the 1.5 m1 positive minus the 1.5 m1 gives us 0. So we're just going to have 5.5 m2 since the m1s are gone. And then on this side, we're going to have 4 m1 plus 1.5 m1 minus 3 m2. Now we want to get m2 on this side. What could we do to this side? We can add 3m2. And then we can add 3m2 to this side. So the m2s on this side cancel because you have plus 3 minus 3, so that gives you 0. So we're going to be left with 4m1 plus 1.5 m1 is equal to 5.5 m2 plus 3 m2. Now we can add the m1s, so 4 plus 1.5 gives you 5.5. And then 5.5 plus 3 gives you 8.5. There we go. So with this, we can basically say that 5.5 m1 is equal to 8.5 m2. If that is the case, then what is 1 m1 equal to in terms of m2? 1 m1 would be divide this side by 5.5 and then divide this side by 5.5. So 1 m1 is equal to 1.55 m2. So the ratio of m1 to m2 is 1 to 1.55. So that would be the ratio of the masses of the two objects. Now it says calculate the total kinetic energy of the two objects before the collision, given that m1 is equal to 8.5 kilograms. Kinetic energy is equal to half mv squared. That's a formula for kinetic energy. Now, if they want us to find the kinetic energy before the collision, we would need to know the masses of the two objects before the collision as well as their velocities. We already have the velocities for the two objects here. One is 4 and one is 3 meters per second. We get the mass for one of the objects, which is 8.5 kilograms, but we need to find the mass of the other one. How do we do that? Well, we can use the ratio down here. Now, a ratio of 1 m1 to 1.55 m2 means that m1 is 1.55 times m2. It's 1.55 times larger than m2. So basically m1 is equal to 1.55 m2. Now, what fraction of m1 is m2? Well, if 1 m1 equal 1.55 m2, then 1 m2 would be equal to 1 divided by 1.55 m1. And then they told us that m1 is 85 kilograms. So it would be 1.55 times m1, which is in this case 85. No, not 85. 8.5. Sorry. 8.5 kilograms. So m2 would be 5.48 kilograms. Now that we have the mass of m2, we can calculate the kinetic energy before the collision. So, the energy before the collision, call it BC, is equal to half 8.5, as 8.5 is m1, times the square of the velocity of m1 before the collision, and the square of that velocity would be 4 squared, so it's 4 squared, so that would just be 16, plus half m, which we worked out to be 5.48, this is m2, times the velocity of m2 squared, So the velocity of m2, even though it's negative, because energy is scalar, the sign isn't taken into consideration. And since the sign isn't taken into consideration, we just call the velocity as positive 3. And the positive 3 squared would give you 9. All we got to do now is multiply this, multiply that, and then add the 2. When we do that, we should get 68 plus 24.8355. And then when we add the 2 of these, we get an answer of 92.66 joules. Calculate the total kinetic energy before the collision. That is done. Now the question asks us, was this an elastic collision? Explain why or why not. Now, an elastic collision is a collision where energy is conserved as well as momentum. An inelastic collision is one where the energy is not conserved. Now, in order to judge if this collision is elastic, we would need to know the energy after the collision. That's one method of doing it, right? And that's the method that we're going to use. You could find out if the collision is elastic from other things, but for this question, we're just going to calculate the energy after the collision and then compare it to the energy before the collision. If they're the same, then the collision is elastic. If they're not the same, the collision is inelastic. So let's get into calculating the energy after the collision. Energy after the collision, EAC, is going to be the same mass. So it's going to be half times the same mass of 8.5. But the velocity is the velocity after the collision. And for M1, that velocity was stated to be 1.5. 1.5 squared is 2.25. And then we're going to add that to half times M2. And then we need the velocity of M2 after the collision. And that velocity was 5.5. 5.5 squared is 30.25. When we multiply these, we should get 9.5625. And we can add the other one when we multiply it, which is 82.885. And then when we add these two together, we should get 92.45 joules. Now let's compare the energy after the collision to the energy before the collision. So the energy before the collision was 92.66 joules. The energy after the collision is 92.45 joules. So we can see that the energy before the collision is more than the energy after the collision. Because they're not the same, we can say that the energy was lost, and we can say that the collision was inelastic just by looking at the data. But you can also say that there might have been some errors in the calculation when it comes to rounding off numbers. And because the errors of rounding off numbers occurred, then you can say that the two values are basically the same and that the collision was elastic. But whichever explanation you choose, you have to make sure that you give the reason for your answer. If you say that it is inelastic, you have to say that it's inelastic because energy was lost and the values are not the same. If you say that it can be considered to be elastic, then you have to tell them why. There might have been a little bit of errors in calculation when it comes to rounding off, so the two values are roughly the same, and because of that, they're basically elastic. Whichever one you choose, you should explain it, because the question asks you to explain your answer. And with that, we would have completed question number 4. If you were able to do all of this in the right amount of time, then you would have acquired 15 marks. That's going to be it for this video. Thank you for watching, and I hope you've learned something.